we're told that you're walking 12 meters in a direction 20 degrees west of north, and then 20 meters in a direction 40 degrees south of west. How far are you from your starting point, and what is the compass direction of a line connecting your starting point to your final position? Okay, so we can represent this with the vectors. I'm going to call this vector A, that is at vector theta A with the, again, this is the y-axis. We're also calling it the north axis, and this is the x-axis. We're also calling it the east axis. So you're walking north at an angle of 20 degrees. Then you turn south at an angle theta B of 40 degrees, and you walk for some time, 20 meters. And how far are you away when you end up? Well, that's just, all they're asking you for is the magnitude of vector R, or the magnitude of vector A plus B. But here's the thing, you can't add these vectors A and B because they're not in the same direction. We need to force them to be in the same direction. So I'm going to take vector A, let me just draw a sketch. So vector A, I can take that and instead draw it as two vectors, AY and AX. And I can do that because this AY and AX ends up in the same distance and direction as vector A started with. So AX, AY. So vector AX plus vector AY equals vector A. But we're just going to use AX and AY. And the same thing is true over here with vector B is somewhere over here and it points like that. I can take this and I can replace it by two vectors, BX and BY. You see, it's the same thing. When you connect them, when you add BX and BY, you get B. But if I put them in horizontal and vertical components, well, I can add BX and AX. I can add BY and AY. They're in the same direction. So if I can add the two components, I can add the two overall vectors. So let's do this. Let's first make a chart of X and Y stuff. So I'm going to start with A. I have theta A, AY, AX, and A. So I can say AX is just equal to A sine of theta A. Because AX is the opposite over adjacent. On the other hand, on the y side, I can say AY is equal to A cosine theta A. And there you have it. But here's another thing I have to do. This is the magnitude of this vector AX. It is the length of that side of the triangle, but the direction is negative. I'm going to have to come in here and I'm going to have to force this to be negative. So AX, the vector, is equal to negative A sine theta A. That is because it's pointing in the negative direction. It's traveled in the negative direction. So what about vector B? That's looking down here. Here we have this, this angle theta B, BX, and BY, where that's a right triangle. So I can say then BX equals negative, again negative because it's going in that direction, negative B cosine theta B. And I have to put theta B there to distinguish it. It's a different angle, so it needs a different symbol. BY, on the other hand, is this time it's negative 2 B sine of theta B. Because see, it's going downward. So once I have these components, basically what I'm doing, if I show this graphically, is I'm taking this situation and I'm turning it into a y, a x, bx, by. But if you notice, you end up in the same position. The resultant vector r is exactly the same whether you do this little square thing or whether you do this thing. Sure, you're traveling greater distance here, but you end up at the same point. That's all we care about, the displacement. So the r vector, the resultant of these two vectors, is the same as the r vector that results from these four vectors. But I can easily add ay and by because they're in the same dimension. I can add ax and bx. So let's do that. I should also say, let me just draw this by itself. So if this is r, then I can define rx and ry. Okay, so rx is just ax plus bx. Rx is then negative a sine theta a minus b cosine theta b. Similarly, ry is equal to ay plus by, which is equal to a cosine theta a minus b sine theta b. Once you plug this stuff in the calculator, you find out that Rx is equal to, what is it, negative 19.425 meters, and Ry is equal to negative 1.579 meters. But we're not done yet. We have Rx, we have Ry. We need to find the length of R, or the magnitude of the R vector, which is just simply the square root of Rx squared plus Ry squared. I have Rx and Ry. So this will equal, what is it, 19.5 meters. That's part of our answer, but the question also asked, what is the direction? So I'm going to need to find this angle, theta r, with respect to the negative x-axis. So I can say tangent of theta r is equal to opposite over adjacent, ry over rx. Again, I'm just using magnitudes here. I can take the inverse tangent of tangent theta r equals inverse tangent ry over rx. Well, the tangent operates on theta sub r. Inverse tangent operates on the tangent of theta sub r to get rid of the tangent, so that leaves theta sub r by itself equals tangent negative 1 ry over rx. If you plug the numbers in, you end up with theta sub r equals 4.65 degrees. And if we look at this directionally, that is south of west, or you could say with respect to the negative x-axis if you define it as the x-axis.